Kia ora Year 12 and Year 11. This is an excellence question from the 2010 Level 2 Calculus exam, and it's a kinematics question. So as usual with kinematics problems, we need to read very carefully before we start doing any maths. A car is travelling at a constant speed of 14 metres per second. So this is velocity before anything's happened. Okay, it passes a sign changing the speed limit to 19.4 metres per second, and it immediately accelerates. The acceleration, A, of the car, t seconds after it passes the sign, is given by this function here. In other words, the car's driving along and it's got velocity of 14 metres per second. The speed limit changes and it slams its foot on the accelerator, and at some time in the future it will get up to the new speed limit, which is 19.4 metres per second or 70 kilometres per hour. And what we're asked to do is to figure out how far the car will have gone before it gets up to that speed. So we want to know about what's going on in here. We've been given an acceleration function, and from that we're going to first of all work out a velocity function, but we're being asked about the distance travelled. So from there we want to work out the displacement function. Okay, so you know from basic kinematics problems that to get from acceleration to velocity we anti-differentiate, and then we're going to anti-differentiate again. But the thing to note here is that the car started out at 14 metres per second, so we're going to define t be the time since the car passes the sign. Now that's done in the question anyway. Right, but what that means is that we know v at 0 is equal to 14. Right, and that's going to help us because we need to get a velocity function. So we'll start doing some maths on the next slide. Okay, so we're starting out with a equals t over 12 plus 0.25. So what will my velocity function be? Well, v of t is going to be t squared times 1 over 2 times 12, 24, plus 0.25 t plus c. But we know that v of 0 is equal to 14, so if we go back and we substitute in 0, we have 14 is equal to 0 plus c, so c is equal to 14. So that gives me a velocity function which is equal to this, 1 over 24 t squared plus 0.25 t plus 14. Right, now looking at the question, we need to figure out how long it will take the car to get up to the new speed limit. So what we're going to do is we're going to solve that velocity equation or function for when is v equal to 19.4. Okay, so the new speed that we're getting to is 19.4. So we'll do this. There we go. Now that's just a quadratic. We need to equate it to 0, so we get 0 is equal to 1/24 t squared plus 0.25 t minus 5.4. Right, now it's fine to reach for your graphics calculator at this point and solve that equation. You're going to have to do the quadratic formula on it, and you're going to get two values of t. You'll get t is equal to negative 14.77 or 8.77, actually 8.7729. So we're going to ignore t equals negative 14.77. Okay, so that's not a valid solution, because that would be 14.77 seconds before the speed limit sign appeared. And we're going to work with this one. So what we're asking now is how far does the car go between 0 and time t? So let's work out my displacement function. So S of t comes from anti-differentiating velocity. Right, so we can, if you've got your pen and paper there, you can work with v of t. So you can see v of t actually still on the screen up here. Right. So when I anti-differentiate that, I'm going to get 1 over 72 t cubed plus 0.25 t squared divided by 2 plus 14t plus c. So let's think again about what we know about S of 0. So this is saying how far has the car gone when the speed limit sign appears. So we know that S of 0 is equal to 0. So again, if we substitute 0 in here, we get c is equal to 0. So that gives me my displacement function. Right, so S of t is going to equal all of this. Right, so c is 0. Okay, so here's my S of t. Right, and hopefully you've seen the last little step, which is the easy bit, is to say what is S at 8.773 seconds. In other words, how far has the car gone in the first 8.773 seconds. And if I substitute that in to my calculator, I will get 141.82 meters. Okay, so the car has gone 141.82 meters before it reaches the 19.4 meters per second limit. Okay, so that's quite a nice kinematics question. It uses all three of the functions, and it gets you thinking about how important it is to know how we're defining t, all right, because that really makes that question not too bad. Thanks for watching, and I'll do some more soon.